All right, let's jump back into this. Now, before I go too deep, what economic principles used in this process was throwing me off last time, so I just chucked into DuckDuckGo MR equals MC economic principle, and it's giving me results profit maximization, the profit maximization rule, profit maximization rule. I'm guessing that since Claude is trained on the internet, it's basically giving that back. Why do we need to make a name for that? We've talked about the primary objective is maximizing profit. I don't think we need to make up a term of the profit maximizing rule. That is, in my professional opinion, a bit dumb. In any case, forget that. You don't need to worry about that. We're profit maximizing. We don't need to make up a name for profit maximizing. Sorry, that grinds my gears. Economics is really bad with jargon, and then trying to create more when we don't need it is George Orwell would be spinning in his grave. And right now I'm spinning for him. Okay, so we were looking at this profit function that we had put together like this. Let's go ahead and say derive revenue equals, it was Q times 1000 minus something Q minus 4Q, which is the same as 1000 Q minus 4Q squared. So this is price times quantity. So we'll get Wolfram to do the derivative for us, and we get 1000 minus 8Q. It's interpreting R as a variable, but it's still doing the right thing. 1000Q minus 8Q. All right, that derivative is fine. What this tells us is that the marginal revenue is declining, right? And it's declining by $8 for every unit that we add. Right? Every extra unit that we sell means that whatever our previous marginal revenue was, we're going to be dropping by 8. Right? Now, our demand function says that every unit we sell, we're going to drop the price by 4. We're dropping our marginal revenue faster than we're dropping the price. We kind of glossed on this graph earlier. Right? So we sell one more unit. We move a little to the right, and our price drops, but the impact this has on our total revenue is more extreme than that. Let me show you a really simple version in a spreadsheet. So if we have price and quantity, and let's say our price can go from 8 down to 0, and our quantity will be 0, and it will work its way up to 8. Our total revenue is price times quantity. So this is just a really simple demand curve, and you can see that we end up with a peak in the middle, right? 4 times 4 gives us 16. If our price goes up, we miss out by selling fewer units. If our price goes down, we make up some of that loss with increased sales, but we lose more by the drop in our price. Right? So here, when we're selling 4 units at $4, if we wanted to sell one more unit, we would be denying ourselves the opportunity to get $4 off of these previous 4 buyers who would have paid us $4. We're only going to have one price in this model, so we lower our price to 3, and we're losing $4 of potential revenue in order to pick up $3 from this one extra sale. So losing 4 to pick up 3 doesn't make sense. We're making less total revenue there. Now our marginal revenue is just how does our revenue change as we're doing this. And in this case, our marginal revenue starts high, gets smaller and smaller, and we want to keep assuming away cost, which we'll come back to in a second. If we just want to maximize total revenue, we want to keep going as long as marginal revenue is positive, but we want to stop before it goes negative. Right? So essentially what we're doing here is we're looking at the impact of selling one more unit on your revenue. So initially, the first unit is the only revenue you get, so it is identical, right? Selling one unit gives you $7 in this simplified model. the marginal impact on your revenue is that $7. But selling a second unit means that your total revenue only increases by $5. Right? So you're selling the second unit, but that means the first guy you would have gotten $7 from, now you only get $6 from him. Plus you get $6 from this other person for a total of $12, which is $5 more than if you'd only sold one. So if we had, for example, a marginal cost of, say, 6 for all of our units, then we could say, in terms of profit, here we're basically going, or let's call it marginal profit. Our marginal profit is positive here, but eventually we want to stop. Sorry, you can't see that. So again, this is a simpler version of the story we're telling. If we just have this constant marginal cost of $6 per unit, then we want to stop, before we get too far. Let's play around with this a little bit. If our marginal cost was $2, in that case, selling one unit adds $5 of profit. Selling a second unit adds another $3 of profit because it adds $5 to our total revenue minus $2 to our additional costs, $3 extra of profit. $1 for the next unit. So in this case, our profit maximizing quantity is going to be 3 at a price of 5. I probably should have switched those columns, but whatever. I'm not going to do it now. So, and actually, hey, before I go too far from here, let me also just show you that other way that we could think about drawing this. So instead of thinking about quantity and profit, which we usually use the letter pi to symbolize, if we instead think of this as marginal revenue and marginal cost. Sorry, this is hard to draw with a mouse. What we're going to expect is our marginal revenue is going to look like this. We're going to have this downward sloping line. And if we had a different function for our demand curve, we'd have a different shape for this. But we've got a simple linear demand curve because what I want you to understand is the mathematics and the model, not the mathematics and more mathematics, if that makes sense. We got to do some of the math, but we're trying to wrap our heads around these models and how to tell stories. Throwing in a quadratic term, it gives you some practice in something, but it's not making you necessarily a better economist. In any case, so there's our marginal revenue. Oops. Next, I only have a line tool. Our marginal cost, probably going to be something like that. And it's going to vary, and actually, for the question that we're dealing with, it's actually different than that. In this case, it's just a straight line. So often in economic models, we expect a marginal cost to look like this. This little uptick at the end is at such a low level that it kind of doesn't really, you don't have to concern yourself too much with this right now, but we expect marginal cost usually be increasing in the real world. But again, we're going to simplify in this quiz to just a constant marginal cost, and that's reflected in the practice questions. So if we've got this, then that tells us that this is the quantity where we're going to maximize our revenue, where marginal cost equals marginal revenue. Going any further, we're going into a place where we're adding more to cost than we are to our revenue by selling more units, right? So we want to stop here. This isn't the graph I was getting ready to show you. Let me show you the graph I actually had in mind. Let's make this a little bit more visible. Let's do this one right. So if we think about, we'll put this in here. Let's make this bigger. Total revenue and total cost. So our total revenue was a quadratic function. Is this going to let me do this? There we go. All right. Oh, come on. Oh, that's just not available. Okay, I get it. So, our total revenue we saw earlier was a parabola. our total cost in this case is just going to be, an upward sloping line. So we got 2,000 fixed cost. Let's change the color here. We got some amount of fixed cost, and then we just add more variable cost the more units we sell. Now, converting this into marginal cost and marginal revenue, we're getting into the calculus part of this. Now, the marginal cost, so this is total cost. To get to marginal cost, we're just getting the slope. Right? And for a line, that's going to be nice and easy. We're using derivatives, but really we're just getting the slope. It's nice and straightforward, and it's going to be the same throughout since we've got a constant marginal cost. Now the question is, where is this total revenue parabola highest above the blue line? That's where we're going to be maximizing maximizing profit. And it's going to turn out, pretend for a second that I drew this parabola a little bit better than I did. It's going to be not at the top of the parabola where we have the most revenue, because we also have higher costs there. It's going to be where the slope is the same for both of these curves. So total cost is increasing $50 per unit. Our total revenue in this model is initially, the marginal revenue is growing fast, right? It's growing faster than $50 per unit. So you sell one more unit, you add $70 to your revenue. It makes sense to make that unit. And then the next unit, we're add $65. And the next unit, we're add $60 to your profit or your revenue. Right? As long as it's bringing in more money, then that's great. But we hit a point where the slope of the red line, the marginal revenue, is less than 50. Right? We hit a point where first it increases, then it hits 50, and then it goes to something less than 50. So if we're adding $45 to our revenue, but we're adding $50 to our cost, that means we're squeezing the gap between those two lines. Once we start squeezing the gap between those two lines, we pass the maximum. Before that point, we're widening the gap between those two lines, and that means we haven't reached our maximum yet. So when the marginal revenue is greater than the marginal cost, we want to make more, but the marginal revenue is going to decline with this parabola, and once it declines to 50, that's where we stop. And that basically corresponds with what we were playing around with here. Once we pass that point where our marginal cost exceeds our marginal revenue, it doesn't make sense to go any further because we're going to be taking $1 away from our profit. As long as I'm here, just to be complete, let's say our profit is going to be our total revenue minus our marginal cost times the number of units we've got. Nice and simple here. And you'll see we add $3, we go up to 8, we add $1, go up to 9, we take away $1, we go down to 8. If our marginal cost was $0, now we're maximizing where we were before. We can play around with this and we can get different results, but we're going to see where we maximize changes based on this, but it really boils down to we're changing the slope of that blue line and we're asking where on the parabola do we hit that same slope. So if this blue line was to get really steep, then we're going to expect to maximize profit a little further back. If our line is relatively flat or even negative, which would be weird, but maybe, but that's going to put our maximum a little further to the right. Right? So the marginal revenue isn't changing, but where it equals the marginal cost changes if we change that marginal cost function. Or we could do it the way we did before, where we roll it all together into something that's incorporating the revenue and the cost, and then we simplify it down into something, and then we do the derivative of that, and we find where does that derivative zero out. That gives us the quantity where we maximize profit. Then we can plug that back into the profit function, and we can find that our maximum revenue is going to be $217,000 divided by 4, right? So $50-ish thousand. All right. I've started on a digression. Let's come back into the questions. All right. I'll be quicker with the rest. hopefully this context is helping you to wrap your head around this stuff. All right, why is the marginal revenue for monopoly always less than the price for any given quantity? I think we kind of touched on that at least well enough for the quiz. A monopoly faces the demand curve 800 minus 2q, constant marginal cost of 100. Without solving, explain how you would set up the problem to find the profit maximizing quantity. So we just mentioned this, right? So either we roll it all together into a profit function and then we solve for the maximum profit using our standard procedure of find first derivative equals 0, check the second order condition to see if we're opening down or up. If we're opening down, we found a maximum. If we're opening up, we found a minimum. For more complicated functions, we might have multiple maxima and minima that we have to evaluate. Just check them individually. All right, so how would we solve this? So that's one way. In this case, there's an easier way. So we know that this is price. We know that for total revenue, we're just going to multiply both terms by q. So we'll have 800q minus 2q squared. We find the derivative of that to get marginal revenue. So that's going to be 800 minus 4q when we do that. So 2q squared is going to derive down to 2 times 2q to the power of 2 minus 1. Let me say it all again. Marginal revenue is going to end up being 800 minus 4q. Write this down. I'm going to try and hold this in my head. We want to find where does that marginal revenue equal 100. So we set those two up equal to each other. 100 minus 800, we're going to get minus 700 equals minus 4q. So q is going to be 700 over 4. Let's see what that is. So equals 700 over 4 is 175. I could have done that in my head, but I don't have to do everything in my head. And let's plug in derive. What was this? This was 800 minus, or let's plot 800 minus 4q. And we want to know where that equals 100. So let's change plot to solve. And we get quantity of 175. Look at that, it worked. So the marginal revenue, marginal cost approach, look at that. We can do it in our head, basically. We've got a little less algebra involved compared to rolling it all into a profit function. So use which approach feels better for you, or which fits the situation better. Personally, it's more intuitive for me to roll it all into a profit function and deal with that. But this marginal revenue, marginal cost trade-off is still a valid approach. Cool, we've solved that. How does the presence of fixed cost affect a monopoly's decisions to shut down in the short run or the long run? So the very long story short here is going to be if you have dramatic fixed costs that eat away all your profits, you want to shut down in the long run. In the short run, fixed costs are sunk costs. So imagine you're running a pizzeria and you're losing money, but it is the 22nd of the month, and you have to ask yourself, do I keep operating for the next week? Well, in the next week, you're not paying any extra rent. The rent is already paid for. You just have to ask yourself whether selling these pizzas will cover your variable costs. Can you cover the cost of ingredients? Can you cover the cost of the gas and the labor that you're going to be employing? If that's the case, then it makes sense to run that last week and then shut down at the end of the week. Because in that week, you're going to shrink your losses. You're still going to be losing money, but you're going to lose less money because you'll be making some money during that week. If you're not covering your costs, then you should shut down immediately because you're digging yourself into a deeper hole. So, for a monopoly, same as for a competitive firm, in the short run, fixed costs are effectively sunk and they can ignore them. The question is, do you cover your variable costs? In the long run, they determine whether or not you're going to be profitable, if they make it so that you are making less profits than in your next best alternative, then in the long run, you want to shut down and get into your next best alternative because it's better than the alternative you're in right now. That's more philosophical than you need to worry about for this quiz. All right, if you calculated the monopoly's optimal quantity is 200 units, explain the steps you take to determine the price at which the firm should sell its product. Let's go back to here. Can I go back? No, I can't. All right. So we find a quantity of 200 is our optimal. There's our quantity and our price. And we want to find out what price can we charge. Now, in the background, maybe the way that we found this is we found where our marginal cost and our marginal revenue cross, and therefore we want to stop before we dig ourselves into a hole. So we found our quantity here. Now we want to know how much do we charge. We just trace up to the demand curve and pretend that's a straight line. So whatever price on the demand curve corresponds with this quantity is the price we're going to charge. So we solve this by finding where does marginal revenue hit marginal cost. We use that to find the quantity. We use the quantity and the demand curve to find the actual price that corresponds with that underlying marginal revenue. Cool. Where'd we go? What is the difference between Monopoly's profit maximizing strategy and a perfectly competitive firm's strategy? Both of them are acting in order to find the point where marginal revenue hits marginal cost. Both of them are trying to maximize profit, and in this model we're assuming that both of them have a decision about quantity to make. Now in the real world, we have many more variables, but if we tried to throw in all those variables into this class right now, it'd be intractable, right? It'd be too much to deal with. So we simplify away, and we're kind of thinking about, really boring firms in a sense, right? Think about like oil. So in, say, Russia, where their oil industry is organized by a monopoly, even if it's not technically a monopoly, you kind of know that the people in charge are going to be having their decisions made by someone above them. So we might have a less competitive industry there compared to, say, in the US. If you're just a farmer in Kansas, you can dig an oil well and you can start selling oil. So in the competitive industry, we're still going to be trying to maximize profits, but we're going to expect the industry overall to push down to where costs equal benefits to the consumers, not where costs equal benefits to the seller. So in a competitive industry, we expect to sell more. We also expect the competitive firms to be making zero economic profit. They're making money, but just enough to cover their opportunity cost, just enough to make it worth their while to not sell their equipment and put the money into the bank getting 5% interest. So their strategy, in both cases, marginal revenue equals marginal cost. But they're going to end up in a different place. The monopolist is going to end up making profits, economic profits, in excess of their opportunity cost, depending on the fixed cost they're facing. And that gets into an interesting question. So if we're thinking about, where'd we go? If we're thinking about a monopoly like this rectangle represents their profits if we ignore their fixed costs. If their fixed costs are really dramatic and eat up all those profits, so if this is profits, but actually most of their profits are paying for some fixed cost, this monopolist might be getting a big skim, but they're spending a lot of it on, say, lobbyists that they need to keep competition out. They might not be as profitable as the model would lead you to believe if you ignore fixed costs. In any case, I'm not going to go down that digression. There's all kinds of interesting things we could think about, but let's get back to the quiz. All right, finally, explain how you calculate a monopoly's total profit once you know its optimal quantity, price, fixed costs, variable costs. Well, hey, we've already actually done that. We've set this up in Excel. So once we find the quantity, we can use that to find the price based on the demand curve. With those, we can find the total revenue, quantity times price. Graphically, this is the area of a rectangle. Right? It is the rectangle of green, blue, and magenta. Right? That is price times quantity. Then we want to know about costs. We take our fixed costs, we add in our variable cost. In this case, it's just $50 times the quantity, which makes life easier. A more complicated, more realistic model, we'd have to do more work here, but still, we'd just be calculating how much are we spending on our variable costs. We add in the fixed cost for total cost, we subtract that number out of total revenue, and that gives us our profit. And check this out, 544, pretty similar to what we were looking at in Wolfram Alpha. Actually, we can calculate this. 217,625. 17625 equals this, divided by 4, 544. Same number. Nice. Cool. So we solved that a variety of ways. Hopefully, going back and forth, pausing, rewinding, taking notes, helps you to wrap your head around this. Like I said, these questions, some of them are really overkill. So this is great studying strategy. If you can get through this, the quiz will be a piece of cake. On the other hand, there's some heavy stuff in here. So don't panic if not everything fits neatly into your head. As you go through more of this, as you get more familiar, this stuff is probably going to click years from now. Maybe not years from now, but it's probably going to click like later on in your career at Farmingdale. It just takes time. But you'll be fine here. Make a good cheat sheet. Feel free to use Wolfram Alpha. It's not going to give you the answers unless you know what to give it. So I want to see that you have enough understanding to make Wolfram Alpha do the work for you, or a spreadsheet or whatever. I don't care about your ability to do the hard work. I just need to see that you understand it enough that you can get the computer to do the hard work. All right, so as usual, if you have any questions, let me know in the usual places, and I will talk to you in the future.